Okay, I push the recording version right now. Let's say hello to camera. Hi. This is AP Calculus AP senior classes. Yay! As we all know, okay, guys. See here, our lesson target today is chapter 3.6, which is a summary for curve sketching. So your lesson target, student can analyze and sketch the graph of curve. Does anybody remember anything about the curve sketching?
Unit domain.
Curve sketching. So Sonny said, what?
Find the domain.
Domain things, great. Let's review a little bit of the previous stuff. Domain, what do we have to know about that? To analyze the curve sketching.
The denominator has to equal to 0.
Denominator has to equal to 0
To find the domain.
to find the domain, great. Anybody else? Anything, just randomly anything, guys.
You have to find asymptote.
Okay, asymptote, great. Asymptote. How many asymptotes do we have?
2.
2. So far it's 2. One for vertical asymptote. Vertical asymptote is how it look like?
Domain.
Domain. Same as domain. It is like writing down x equal the number, right? Another second thing is horizontal asymptote. So one for vertical asymptote, another for horizontal asymptote. How many know about the horizontal asymptote?
Horizontal is end behavior.
Yes, it's end behavior.
Vertical is DNA가 something that makes
Something that makes DNA.
yeah
What is that for?
for X.
Critical value. Yes. Critical value. Another main critical point. Critical number. These are the same thing. That definition is the number which make it f prime of x equal to 0. DNA was important. Okay. What about other things?
Intercept.
Intercept, great. Intercept is coming from the algebra tool, which is x-intercept and y-intercept. How we get the x-intercept?
Y equals 0.
Yes, put y equals 0. Then we have to solve it for x. Solve for x. That is your. Oh, sorry. Solve for x. So y-intercept. X equals 0. Then solve for y. Great. Anybody else? 동재.
Yes.
Anything about the curve sketching from the previous class?
Curve sketching.
Yes. So far we have these things, but anything.
Interval.
Interval.
Yes.
Yes, interval. So after we finding out the critical value, we have to sort of separate the intervals.
Yeah.
Because we have to know f prime of f sine and 2 prime sine and finally conclusion. So these are things, intervals we have to divide out with the critical value between the intervals, right?
Yeah.
Okay. I think I'm going to teach later than one more asymptote. I'm going to introduce you the slant asymptote. Slant asymptote today. Slant. The slant. So vertical asymptote is looking like that, right?
Yeah.
It's exactly the straight line. Horizontal asymptote is asymptote look like? Like that.
Ooh, that's very.
Looks interesting, right?
No, Shibel.
Okay. Let's go over the 1-2 question. The homework question.
Yeah.
Any questions so far, guys?
No.
No. Okay. Number 1. Analyze y equals 3x over
X minus 1.
x squared minus 1. Which group was the give us presentation? Group 2, okay. Please come up to the group 2 members.
처음으로.
Centers are sorry. Are you guys ready?
Yes.
Okay, let's go.
Okay, guys. So today, hey, everybody, listen. So today we're gonna explain how to draw the graph for this, and let's begin.
First, we have to find domain. To identify domain, number has to be 0. So, x square minus 1 equals 0. So, x so plus minus 1. And second, we have to find x and y intercept. First, x-intercept put the 0 on y. So 0 equals so x-intercept
Is 0.
yes. So, and then y-intercept put the 0 on x. So y-intercept is 0.
So first question, identify domain and identify all x and y intercept. The Adam said 0, 0 was one of the points as the x and y intercept, right?
Yeah.
And the domain is all real number
Except
except x equals plus minus 1. Okay. Does everybody agree with that? Yes, let's move on. Number C.
Third one, you have to determine the end behavior of the function. First, you have to write limit to of x equals to infinite and infinite with this function, original function, and minus infinite to minus infinite 2. So the numerator is bigger than the power of the numerator. 부모 is bigger than 분다, so it should be 0, and this is also 0. So this is the behavior of the function. Fourth, you have to identify all asymptotes. We should figure out the vertical asymptote and horizontal asymptote. As at the beginning, the domain was plus minus 1. So it's plus minus 1. So vertical asymptote can be plus minus 1. And except plus minus 1. So x equals plus minus 1. So and horizontal asymptote is y equals 0. As you see, this is an behavior function. So as looking at this function, you can see that y is 0.
Oh, any question?
No.
No? We have the same answer for that?
Yay!
Okay.
Okay,
Next.
then after this, we're gonna start to differentiate. And first, we're gonna do first 1 prime. And then we're gonna do all together.
Okay.
So this 1 prime, when you do the differentiate, you have to do 남이분 너 그대로, 너미분 나 그대로. So here you given the first one, and then it goes up all together, and minus that goes same, and then you differentiate this one, and it becomes 2x, and then denominator it becomes you square the denominator. So this is the y prime. And then if you calculate it with your brain, it comes out to be 3x squared minus 3 over x squared minus 1 squared. And then again, you have to do the 2 prime. So here you do the 2 prime.
So we differentiate this again. Okay, so we 일단 제곱 분모, and then we sorry.
You square it again because it's 4.
남이분 너 그대로 빼기 나 그대로 너미분, right?
Yes.
So
It doesn't talk much, but then you know. And then you put the minus sign, and then you do the even for the first one, and then you have to do the even for the denominator. And x squared. And then you multiply, you get rid of all the things that are same, and then this comes out to be 6x cubed plus 18x over x squared minus 1 to the cube. So this is 2 prime of x. And then
Is everybody the same?
Yeah.
Yeah.
and then we're gonna make a chart now.
Okay.
Wow, sure. So let's make a chart. Can you draw the chart? Oh, okay. But then when you draw the chart, you have to know your 1 prime and your 2 prime. But then in the 1 prime, x could only equal to plus minus 1. But then you have to look at the 2nd prime again. And then here you have 0 as well. So when you make the chart, you have to make for both plus minus 1 and 0.
Okay.
So let's begin with this. Negative 1, 0, 1, and then you do the
So negative 1 and 1 coming from the critical points after first derivative. And then 0 was the second derivative.
Yes.
Was that? Okay, great.
Okay, perfect. So here we did the vertical asymptote in the beginning, and we know that negative 1 and 1 is the vertical asymptote. So you draw the line like this. Yeah. And then that's what VA, VA. And then you plug in the points. You plug in the numbers for the prime x. And then when you do that, when you plug it in, it becomes negative, negative. And then even if this is a point of 0, a minus sign. And so it's negative again, and again. And to make the time short, we just did it.
Okay.
And then let's do the second two part.
어.
But are we sure there is all negative at the first derivative test?
Yeah.
What does the negative means?
Yeah. Decreasing.
Decreasing
Oh,
of the.
the first one is decreasing.
Okay.
So we did a two part.
When we plug in, such as -2 inside two prime of this, you get negative, positive, negative, positive, right?
Yes!
But yeah, so only changing the changing sign is in here because these two are
Vertical verticals.
so we can know that this is
P.
Yay!
Yay.
And then here you get the POI, but then how do you find the POI?
Plug in.
0 to original function. That's right. So when you plug the 0, it becomes the 0, comma 0. So we are very close to getting the graph. Okay, and then to make the graph, to draw the graph easier, this is negative and this is negative, so it has to go down. You have to use this side. And then here, it's going down, and then it's positive, so you use here. And going down, down, here, down, and up, so here. So you have to use these to draw the graph. And then, let's start with the graph. And then, she's drawing the vertical asymptote. Yeah. And then, let's do you guys remember the end behavior?
Yeah.
They were
0.
That's right. So when you draw the graph, you have to conclude to 0. Okay?
Yes.
And then, what's the POI?
Function.
And that was?
Sign.
What was POI on the graph?
Zero.
That's right. So here, the graph has to go like this and then like this. So you have to go over 0.0. So it comes all the way down and then crosses and then it goes all the way down. And then here, it's -1. So, but then the graph it has to go like this, right? Yeah. Then it can't go over there. So you have to put it down. So when you draw it, this is the vertical asymptote, and you can't touch -1. So it has to go like this. And then here, the end behavior is 0 again. So, but then it has to start from the up. Okay? Okay?
Yes.
So you start from here, and it goes all the way like this.
Oh.
So, this is how you draw the graph for x squared negative minus 1 분의 x, 3x.
Groups of two. We
don't have to explain like the increase and decrease.
No.
Don't be ready. Great job. Guys. So they are agreed to finding out the order critical value, and then F was the interval from increasing and decreasing, but they are looking like decrease, 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 decrease. So the graph and then the chart was the same, right?
Yeah.
Okay. Is there any local maximum and minimum, guys?
No.
Is there any local maximum and minimum?
No.
Question again. Adam,
Yes.
why? Can you tell only looking at the table why we don't have a local minimum and maximum?
Because at f prime
Yes.
doesn't change plus and minus.
Yes, exactly. There is no sign change in here, so you can tell there is no minimum and any maximum. Even though we divide by -1, 0 to 1. This is the possible number, can be the critical point, either like the points from the local minimum and maximum, but sometimes the position vertical asymptote in there is no local maximum and minimum. So please keep that in mind. And another thing, is there any absolute minimum and maximum in here?
No.
Why?
Everything is going to infinity.
Yes. Hyunso mentioned it really great because it goes up and down in here. Not in here because this one is the converge to 0. But here going up and going down, so there is no maximum and minimums there. Oh, have a question.
Isn't the horizontal asymptote was 0, but then the graph touched the 0?
This one, right?
No.
This one.